Basically, there are two key questions from our work package. So the first one is the contribution of the contribution DAMS can make to global energy mix that is compatible with the Paris 1.5. Sorry, I think I'm trying to adjust there. And then the role of dam construction and operation in a national context, Ghana as a case study. So one is the global energy mix at global level, what the emissions from the dams, and secondly, how does it in the context of the Ghana. And also a review of methane emissions from the dam reservoirs at the global level. So these are the two questions we are trying to address in this work package. So the work so far has been a literature review to understand the greenhouse gas emissions from the existing reservoirs, then developing some methods to estimate emissions from large dams which are planned and under construction. So that's the work we have been doing so far, and also a little bit about the GRS tool to estimate emissions from the Akosombo Dam in Ghana. So in the initial findings, so far, we got about 9,266 hydropower plants globally, which contributes about 2.5% of final energy demand globally, which is about 16% of electricity. But also hydro has got a theoretical potential about 52,000 terawatt, which is about 12 times of the electricity generation from hydro plants now. And about 35,000 terawatt is from large hydro, that is about 10 megawatts. And we got about 700 gigawatt capacity of dams which are planned or under construction. That gives another 2% of demand. So there are several scenarios. So the World Energy Council has got a recent publications. They say about 6,000 to 7,000 terawatt hours of electricity is coming from hydro by 2050. So that means about 4 to 6% of final energy demand from hydro. So hydro is still going to be one of the key energy sources in future, whichever we decide. So the problems with the hydro is in terms of carbon, there's a huge variation in emissions intensity between literatures. So there are 2 to 3 orders of magnitude from different reservoirs. So the provisional estimates suggest that about 200 to 300 kilograms CO2 per megawatt hour for all dams globally. So that's from different climate zones, from temperate, tropical, boreal, etc. And this includes the biogenic and construction, but it doesn't include the pre-impoundment emissions. I'll come back to that a bit later. But so some literature suggests, for example, the IPCC AR5 in their report, the hydro emissions are about 24 kilograms CO2 per megawatt hour. Then you can also find in literature like the tropical reservoirs has got very high emissions intensity, about 1,300 to 3,000 kilograms CO2 per megawatt hour. To put in context, the coal power station is about 900 to 1,000 kilograms CO2 per megawatt hour. So it's worse than coal if it is from a tropical reservoir. And also I put one of the worst hydro reservoir, the Balbino in Brazil. So one of the recent studies suggests it can be up to 3,900 kilograms CO2. So it can be very high to very low. So it's a huge variation in terms of emission intensity from different locations. So some of the factors to be considered or challenges, I would say. So there is a lack of clear methodology to assess the greenhouse gas footprint. Then there is an issue with the pre-impoundment and post-impoundment balances. some of the literature now, which is suggesting hydro's high emissions. They haven't looked into the pre-impoundment balances, but so some literature suggests, to account the actual emissions from a reservoir, you should consider both pre and post impoundment balances. But then there are issues about the measurement. How do you measure the pre-impoundment emissions? And also some literature, what is included and excluded is quite challenging. So you should include construction biogenic emissions. So some of the reservoir emissions, they don't consider the construction emissions. So the clear accounting methodology, what is included and excluded, is quite important. The lots of estimates in the literature currently, they are based on annual aerial rates. So they take measurements in a particular year, and then they assume, so they are sampled locations. So then assumed those aerial rates are same for the total surface area within the reservoir. However, the emissions vary significantly from year on year from the time of the dam construction in the future, so they are not consistent also. The footprint estimates provided for dams are typically over 100 years. That's how it's given now. Most of the emissions for all the dams are, if it is in CO2e, it's CH4, but so 80% of all dam greenhouse gases are CH4. However, this is one of the issues, is the most biogenic emissions occur in the first 20 years. And it's not just the CO2, but the CH4 is all the same, that most of the emissions occur in the first few years, and then it gradually decreases over the time. And this is quite important for the Paris Agreement, because the Paris Agreement suggests that we should get to net zero emissions in about 2050 to 2060. So if you're looking at 1.5 degrees Celsius, because most of these emissions occur in the first 20 years or so, so that is quite problematic. Perhaps for 2 degrees Celsius is less of a problem, but for 1.5 degrees Celsius target, this is a big problem. So these are some of the issues I have come across. Some indicative numbers. So the annual hydro reservoir greenhouse gas emissions is about 767 million tons CO2e. That's the post-impoundment emissions. That's about 1.5% of global emissions currently. And most new dams planned are in developing countries, which is either in temperate or in tropical countries, which has got very high CO2 intensity. So that means new dams potentially can contribute a significant amount of emissions, which may not be compatible with the Paris Agreement. And also a lot of countries in their nationally determined contributions, they included hydro as one of the way of reducing their country's emissions. So that is challenging. So the Ghana case study, Akosombo is the largest dam in Ghana, and the hydro contributes about 35% of electricity demand in Ghana. And there is a potential for about 2.5 gigawatt of hydro in Ghana. The existing dams, Akosombo and the proposed Pualgo, are in the lowlands of tropical area, which has got a very high emission intensity. So I have pulled out from some literature the emissions, how it is in Akosombo. So you can see the CO2 and CH4 emissions from Akosombo is very high, near to 1,700 grams of CO2 equivalent per kilowatt hour for Akosombo. And then the Ghana, the average emission intensity is also quite high, and Africa, I put the Africa as well from the literature. So on the bottom left-hand side, I put the emission intensity for some other technologies. How does hydro compare with other technologies as well? So depending on the location, if it is in the lowlands of tropical regions, it can be quite high, definitely more than a gas power station. So the site where it is located is really important in terms of carbon emissions from hydro. So that's sort of a work plan I have made. So far, as you can see from the work plan, I've been largely focusing on the literature review and trying to create a database for the dams. So the plan is across the spring, summer, and autumn, I'll be doing most of the research. So the research question 1 is the greenhouse gas emissions from the future dams and the dams in Ghana. So there will be some initial research I'll be doing across spring, autumn, and summer this year. And then the next year, I'll be start writing papers. So I'm thinking of 3 papers from this project. So that's the current plan. Happy to take any questions.
Do you have titles for those papers, Jaise?
Not quite, but